solve some integrals using substitution. The first integral is the integral of the function 1 over x, the natural logarithm of x minus 2 in the x. Okay, so this is the first integral. Here we basically can notice that 1 over x is the derivative of this function of the log of x minus 2. So that means that this function here in the brackets is basically the inner function, and this function will be the derivative of a composite function in which this is the inner function. Maybe we can write the integral like so. Okay, so as I said, 1 over x is the derivative of this. So in these cases we can resort to the substitution. So it means that we can substitute the inner function, so this function that we have here at the denominator, with a new variable. So we can we can call the new variable y, and y will be the natural log of x minus 2. Okay, and when you do substitution, when you consider a substitution, you have also to write the infinitesimal term with respect to the new variable. So that basically means that dx has to be transformed in dy, and to find dy we have to consider this relation, and in particular we have to consider the derivative of y with respect to x. Okay, so basically the derivative of the new variable with respect to the old variable, let's say. But since y is this, we have to consider the derivative of this, but as we said, the derivative of this is just 1 over x. So this basically means that from this equation we can say that dy, the new infinitesimal term, will be dx over x, and here we basically moved dx on the right side of the equation, and we obtain this relation between dy and dx. And here, as you can see, the denominator is basically this one. So here at the denominator we have dx and 1 over x. So this means that as numerator we will have dy, and as denominator we will have just y, because y is this expression. So this means that the new integral will be dy over y. Okay, so this is the new form of the integral with respect to the new variable. And now, as you can see, the integral is much easier. And in fact, this integral is just the natural log of y. We have to add first of all c, so the constant, because this integral is indefinite, and we also need to add the absolute value. We need to result will be the natural log of x minus 2 plus c. And note that here we need the absolute value because we do not know the sign of this expression, and on the other hand we do not need the absolute value here for x because basically we are taking for granted that x is positive, since here there is no absolute value. So this is our first this was our first integral, sort of icebreaker. The second integral, so let's move to the second integral, is a definite integral, and it is the integral between -1 and 0 of the function e to the x over cosine squared of e to the x for dx. Okay, so this is our second integral, and here also in this case it is quite natural to consider a substitution because here again, as in the first integral, we have e to the x, which is the derivative of e to the x, and so that means basically that e to the x is somehow the inner function of a composite function, and this expression is somehow the derivative of a composite function in which we used obviously the chain rule. So this means again that we need to consider a substitution, and again we are going to substitute the inner function, so e to the x, with a new variable. We can use, for example, t in this case, so t is the new variable and is equal to the inner function. So again we need also to consider the derivative of t with respect to x, so the derivative of the new variable with respect to the old one. Okay, so since t is e to the x, the derivative of t will be just e to the x, but this means that we can move the x on the right side of this relation. This means that dt, so the new infinitesimal term, will be e to the x times dx, which is again what we have here as a numerator. Okay, so as last step, since this integral is definite, we also have to transform the limits of the integral. Since these limits -1 and 0, these limits refer to, let's say, the old variable, so they refer to x. But now we are transforming the integral in terms of t. So that means basically that we have to study how the new variable, so we have to study how t behaves when x is -1 and how t behaves when x is 0. So for this last step we have to consider the two minus 1, then t, let's call it t1, so the new limit in terms of t with respect to t. t1 will be e to the minus 1 because t is e to the x. And similarly, for the second limit, let's call it x2, which is 0. We have second limit in terms of t will be e to the 0, which is obviously 1. Okay, so these two, e to the minus 1 and 1, are the new limits of the integral. At this point we can transform the integral in terms of t. So first of all, the two limits, the first limit is e to the minus 1 and the second limit is just 1. And then, as we said, e to the x is t, and e to the x times the dx is the new infinitesimal term. So e to the x dx is just dt. And then we have cosine squared of t, because e to the x is t. Okay, so at this point we can compute the integral, which is quite easy actually, because the integral of 1 over cosine squared of t is the tangent of t, because the derivative of the tangent is 1 over cosine squared. So the primitive function will be tangent of t. And since this function, this integral is definite, we have to study this function between e to the minus 1 and 1. So we are going to study this function between these two limits. So that means that tangent, the result will be tangent of 1 minus tangent of e to the minus 1. Let's move to the third exercise. Okay, so the last exercise is another indefinite integral, and it is the integral of e to the x over e to the 2x, e to the 2x over e to the x plus 1 in the x. Okay, so this one is probably a bit trickier compared to the other two integrals, because here it is not very clear where the inner function and the outer function is, but actually you can somehow find a solution if you write e to the 2x as e to the x times e to the x. So I'm basically saying that we can write this integral as e to the x times e to the x over e to the x plus 1 dx. And we are doing this because basically this term e to the x dx can be our new infinitesimal term with respect to the new variable. So maybe it would be easier to understand if I write down the substitution. So the substitution in this case will be y, so y is the new variable, equal to e to the x because if we consider this substitution, we have that, as we saw previously with dy is e to the x times dx, which is the function, which is the term here. So that means that our new integral here will be the integral of y over y plus 1 dy, because as we said, e to the x times dx is dy, and then we have y and y here. Okay, so this is our new integral in terms of the new variable, and here it is convenient to sum and subtract by 1. So I'm basically saying that here we can write y plus 1 minus 1 over 1 plus 1 dy, and we are doing so so that we can resort to the rules of the ratio. So that means that we can consider y plus 1 over 1 y plus 1 minus 1 over y plus 1. So we basically split into two fractions this rational function. So it means that we get 1 over y plus 1 dy minus no, I'm sorry, we will get minus 1 plus dy. Yes, okay. So we basically obtain two integrals, and these integrals are easy to solve because the first integral is just the natural logarithm of y plus 1. So this one, and again with minus, and again we need the absolute value, plus y, and then plus the constant because it is a indefinite integral. So we get e to the x minus natural log of e to the x plus 1 plus c, and this is the final result.